Space weather latest, they have a new sunspot from an old solar cycle, and we're going to look at the asteroids, the near-Earth objects that are close to us as well. A new sunspot on the sun, of course. A new sunspot is emerging in the sun's northern hemisphere, numbered AR 2757. Its magnetic polarity identifies it as a member of old solar cycle 24, the one before this one. And these types of sunspots will become increasingly rare in the weeks and months to come, as the old solar cycle 24 leaves us and the new solar cycle 25 intensify to replace it. AR 2757 poses no threat for strong solar flares. We've also seen polar stratospheric clouds. For the second day in a row, these polar stratospheric clouds, or PSCs, appeared over Sweden. And according to Jordan Herbst of Earth to Sky Calculus, who lives in Sweden, in Abisko, Sweden, he says, "I couldn't believe my eyes when I looked out the window this morning and saw a series of cosmic ray balloon launches. I rushed outside, post-holing through deep snow to set up my camera and a good view of Lapperton. Images of clouds floating over Mount Nisunjaro." Now, the polar stratospheric clouds are very rare. They look like iridescent clouds, basically. Normally, the stratosphere has no clouds at all. PSCs form when the temperature in the Arctic stratosphere drops to staggering very low, minus 85 degrees Celsius. So then only do these sparse water molecules begin to coalesce into tiny ice crystals. This is what makes up the polar stratospheric clouds. So the ice reflects the air, making it look like it's a rainbow cloud. So these high altitude sunlit shining through crystal creates the intense iridescent colors as if it's a rainbow cloud. So in a typical Arctic winter, these polar stratospheric clouds appear 2 or 3 times at the most. And this winter is different. The clouds have nearly filled Arctic skies on dozens of occasions, it says here. Some longtime residents describe the best outbreak in this generation. As far as the All-Sky Fireball Network, January 24th, the network reported 12 fireballs. They're sporadics. Every night, NASA all-sky cameras scan the skies over the United States for meteoric fireballs. This automated software maintained by NASA's Meteoroid Environment Office calculates their orbits, their speed, penetration depth into Earth's atmosphere, and many other characteristics. And the daily results are here on space weather. So 12 sporadics, all intersecting at Earth. This is the diagram of the inner solar system. All of the fireball orbits intersect at one single point, that is our Earth. The orbits are color-coded, velocity from slow being red to fast being blue, and these are green and blue, so you can see that they're pretty fast. And we have a listing of recent and upcoming Earth asteroid encounters, near-Earth asteroids, potentially hazardous asteroids, are space rocks larger than about 100 meters, that's 300 feet across, that can come closer to Earth than 0.05 AU. None of the known PHAs is on a collision course with our planet, although astronomers are finding new ones all the time. Now, the one that we had January 20th was a velocity of 10.5 kilometers per second, diameter 15 meters, that's about 50 feet across, and it was a very short distance, 0.8 lunar distances. Now after that was January 22nd, it's already passed, 0.7 lunar distances, 9 kilometers per second, and that was small, that was 4 meters, that's about 12 feet across. And the next one will be today actually. It's very short distance, 0.2 lunar distances, speed of 10.2 kilometers per second, and that's 6 meters, about 20 feet across. The next one after that is February 4th in about a week. That's way out. It's 3.7 lunar distances, going at 7.4 kilometers per second. That's a bigger one. It's 28 meters across, about 90 feet across. Now, the cosmic rays in our atmosphere. Yes, we have a lot more coming in because we have a decreased magnetosphere. Now, something new, he says we have developed a new predictive model of aviation radiation. It's called ERAD, short for Empirical Radiation Model. Constantly flying radiation sensors on board airplanes over the US and worldwide. They've collected more than 22 GPS-tagged radiation measurements, and using this unique data set, we can predict the dosage on any flight over the US with an error no worse than 15%. And they have a hot flight schedule. It shows the 5 charter flight, 5 highest dose rates, 5 commercial flights with near average dose rates, etc. So the hot flights for today, January 24th, are basically the ones, the higher up you go and the more hours you go, it's logarithmically increases the amount of radiation that you have. So, for example, if you're at a 22,500 feet flight for an altitude of 28,000 feet flight, you get a dosage rate of 22.5. That's about an hour flight. Whereas if you're at an hour's flight about 40,000 feet, you have over twice that. It's 55.9 dose rates. So you can understand the same amount of flying, but over twice as much. In altitude, you get almost 3 times the radiation. Now, to measure it, they use, on the airplanes, they use same sensors that they fly to a stratospheric onboard Earth-to-sky calculus. They can use cosmic ray balloons, neutron bubble chambers with X-ray, gamma ray, Geiger tubes sensitive to energies, and these energies span the range of medical X-ray machines and airport security cameras. Space weather balloons. The students of Earth-to-sky calculus fly space weather balloons to the stratosphere over California. The balloons are equipped with radiation sensors to detect cosmic rays. And these cosmic rays can seed clouds, trigger lightning, penetrate commercial airplanes. And there are studies linking cosmic rays with cardiac arrhythmias and sudden cardiac death in the general population. The latest measurements show that these cosmic rays are intensifying, and there's an increase of more than 18% of these cosmic rays since 2015. That's shocking. Now, the dose rates we said concerning the flights, why are cosmic rays intensifying? The main reason is the sun. Solar storm clouds, such as coronal mass ejections, the CME, sweep aside cosmic rays when they pass by Earth. During solar maximum, the CMEs are abundant and cosmic rays are held away from Earth. But now that we're in the solar cycle swinging towards solar minimum, the cosmic rays are allowed to return, bombarding Earth. And you can understand how dangerous that is. Another reason could be the weakening of Earth's magnetic field. The Earth's magnetic field, of course, helps protect us from deep space radiation. And it's weakening, unfortunately. Now, the scientists don't know why it's weakening. I'll leave links below for you for this on space weather. And you can see the beautiful pictures of the iridescent clouds. They look like beautiful colored rainbow clouds because of the ice crystals reflecting the light. This is on space weather. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.